Okay, example is an introduction, a demonstration of Lisp in an indentation-based syntax, which is calcit in this demo. So calcit was a script language designed based on ClosesScript syntax, and it shares some common syntax, some common APIs and semantics from ClosesScript, and so by design, calcit runs with a snapshot file, which is a data file, and actually not a source code file. So to run calcit with text indentation based syntax, I have to run bundle calcit first, which bundles the source code into a snapshot file, and then run it with cr command, which stands for calcit runner. So here are some examples of writing calcit in indentation-based syntax. A very simple function to run. Okay. Personally, I was using CoffeeScript, which is a dialect of JavaScript, but in Ruby syntax. I wrote it for years to make web apps, so I feel very accustomed, very natural to have indentations in my code. In the early days, when there was no prior, but with prior today, it's not very hard task to write TypeScript or write JavaScript. Since strange. So that was the first example, and now the second example is to write code with quote. We don't have JavaScript we don't have quote in JavaScript in C, but in Lisp there's a quote function or quote special form for turning code into data, into a list. So in this demo, I turning quote into actually I know there was a mistake in the video I recorded 2 years ago. But it still runs. Okay. So with quote, we can turn code into data and then manipulate data and then turn it into code back, which is called metaprogramming. And it's very powerful with metaprogramming to run to create programs dynamically. So it's very powerful trick, although it comes with some cost. And I have to mention in this demo, since there was a warning, the warning says macro should already be handled during pre-processing, which means there is a pre-processing stage in calcit which resolves symbols and expands macros before the program is actually running. Okay, this is a symbol of recursion. Actually, I'm not demonstrating tail recursion. It's just very simple recursion with if and with indentations. You may infer the structure from the structure, from the indentations. When there is indentation, it creates new expression wrapped with parentheses mentally, virtually. So something might be tricky to do is to write code with condition expression, because condition expression wraps conditions and which makes nested and pairs of nested expressions. So I have to use inline parentheses to wrap the condition part. So this is a very simple example because it's still very simple. It's just demonstrating that when I want to put an expression at the head of the expression, so an expression at the head expression, so I have to use inline, use parentheses. But there's some still tricky case. The let expression. So let expression has a pair of boundings. So the first node, the second node in this expression, it's an expression with pairs of nodes, pairs of boundings. So I have to indent it twice. When you see here, if you look at here carefully, it's indented with 4 spaces and then go back to 2 space to create a nested structure. Luckily it works, but if I still want to use another expression at the head, so I still have to use parentheses to wrap the expression to make it inline, even if it's even if it's longer than this one. So I suppose this might be the most tricky part in using indentations with Lisp, to create multiple levels of indentations in a single expression. Okay. It was rather tricky. And for hash maps, since 0, the syntax behind calcit, which does not allow parentheses to be used in different lines, opened and closed in different lines, so I have to use prefixed hash maps syntax, which is actually a function or a macro that wraps a function. So end hash map is the internal function of a hash map. The hash map function with only brackets, the curly with only curly brackets, that was a macro. So this one is the internal function that calcit handles. So here is a training demo using thread macros from Clojure. Actually, Clojure uses 2 thread macros normally. One for putting the arguments at the first of arguments, and one putting at the end, at the tail. But in Calcit, I changed the semantics to put all the operands, the list, the hash map, they all put the operand at the first argument. It has very good result of training everything. In Clojure, it has a tradition of using partial functions, which is a tradition from Haskell, from Lisp, since they can create partial functions and then reuse the partial function to apply it on different lists. So that was very good, very nice usage. But it comes with the cost of creating partial functions, which is not implemented, not optimized well in Calcit. And also, I still want to train everything, so I unified the syntax and relying on macros. That is this thread macro to train different functions, different operations. It turned out to be quite neat. If you look at this example, even neat than Clojure. And Clojure uses partial functions in transducers as well, which is also not well supported in Calcit. Okay, this demo is IIFE, immediately invoked function expression. So this demo mainly wants to tell you that when you want to put an expression at the head, you have to wrap it with parentheses. So normally we don't do this. So this is just a demonstration of writing large expressions at here because expression head may have some effects on the rest part of the code, or anything that behind it. So you can see from the demo, it's very tricky. Even myself get confused of how to make it really work. Actually, I made a mistake here in the example. It was an example made two days ago. Okay, fighting the bug. Actually, I normally when I encounter this problem, I use a macro called apply arguments, which uses macro to change the order of the expression, the arguments, the nodes in the expression. So let's try the example apply arguments, which is which is very similar to the function apply. So when it's using apply arguments, it's just putting the arguments at the first with the list, and use a macro to call, and now it works. It's not printed. So after all, I want to show indentations. So putting indentations at head, which is a very tricky solution, a tricky way of writing code. But it should work at many cases. Yes, it worked. Not a very good example. It confused myself. So I'm leaving here to just as a demonstration that it's very tricky to deal with indentations at the head of an expression. So you already saw it. One more example is to operate on macros. So Calcit uses prefix syntax, uses macros, and then I call it a Lisp dialect, even though it's not using parentheses. People may pretend to think that Lisp comes with expressions, but actually, I should say in my own opinion, I think Lisp most importantly it uses prefix syntax uses macros, which has the power of code as data. It also has a feature called homogeneity, which means its code and its syntax tree has the same structure. So even compared with Ruby with Rust, which has support for metaprogramming with macros, Lisp is still more natural, more flexible. So anyway, in this demo, I'm just going to create code with data, which just manually create data, create code from data. So first I created a function, created the arguments, and then I'm going to change the functions to make data and finally to evaluate, which is how we create programs dynamically in Lisp. Although this is very simplified example. So maybe I use numbers. And eval the function. Yes. So this is the example. Thanks for watching.